In this episode of Scaling Postgres, we talk about column performance, BRIN when, unique and null, and parallel distinct. I'm Preston Jameson, and this is Scaling Postgres, episode 224. All right, I hope you, your friends, family, and coworkers continue to do well. Our first piece of content is column order in PostgreSQL does matter. This is from cybertech-postgresql.com, and it's talking about column order, but more specifically, I think it's talking about when you have too many columns, it can really cause an impact with performance in certain cases. Now, the order comes in when you have a lot of columns on the table and you're looking for something specific in one of the later columns, but we'll get into this post. So basically, they had some clients that had some very broad tables. So he simulated one. He's using generate series and the /gexec command to create a really wide table, essentially 1,500 columns. So that's a lot of columns. And then he inserted 1 million rows into this table for doing these tests. Now the size of the table was about 4 gigabytes, so not incredibly large. Now first he just wanted to get a count all the rows from this particular table, and it returned in about 400 milliseconds. So there's no index, it's just doing a count of the rows that exist there, and it's doing it in a parallel sequential scan here. Now when you choose the first column and do the same thing, you have something similar. It's a little bit slower because it does need to check for nulls for the data in this column. So as opposed to being 416 milliseconds, this one was 432 milliseconds, but still not bad. But look what happens if you select the 100th column where you're doing a count on that. Now suddenly it's twice as slow. It's 857 milliseconds. So I was pretty surprised it gets that drastic at only 100 columns. And then when it goes out to the 1,000th column, it takes over 8.5 seconds to return a count from those rows. So that's crazy. That's 20 times slower than before. Now he says why this is happening is that basically he has to pull back a row and then use the data types of that table to figure out where the data is located within that row to be able to return it. Now, this can be relatively easy to do if there's a bunch of integers because they're essentially just 4 bytes. But with text-based ones like variable character data types, the computation gets a little bit long, and having to do that for every row that you're counting really adds up. So basically, as he says here, having that many columns in a table, quote, does create some non-trivial overhead. So just be careful about making your tables too wide because you may run into performance issues. But definitely check out this blog post if you want to learn more. Next piece of content, Postgres indexing. When does BRIN win? This is from crunchydata.com, and he's talking about BRIN indexes, which are basically a block range index. And as the name implies, it indexes ranges of values. Unlike a btree index, the typical index that indexes every value, a BRIN index does not do that. It does ranges of values. Now, as a consequence, it's going to be a lot smaller, this type of index. And one of the disadvantages you can imagine, it's harder to pull out a distinct value. Whereas with a btree, it's quite easy to pull out a distinct value. Whereas with a BRIN, you have to pull back the range and then find the individual value you're looking for. Now, the other consequence is that it does really well with sequential data, but not so great with random data. So he has some examples here. If you have like a log table with a timestamp and you put a BRIN index on the timestamp where you're pulling back ranges of data, that could be a good use case. Or different types of sensor measurements or GPS tracking points, etc. Now he goes into describing a little bit about the BRIN index and how it's structured, but basically there's a value range that index holds and tells you where in the pages to find those values. So again, the more that your values are grouped together physically in the heap, the more efficient a BRIN index will be, because you don't want it to have to go to multiple pages across the heap to find a particular range, because then the index becomes very ineffective. Now he created a table here where he had some random data and some sequential data and a value, and he created 4 different indexes, 2 btree, 2 BRIN, and for each type he did the random column and the sequential column on the table. Now again, because the BRIN indexes only ranges and not distinct values, you can tell how much smaller the BRIN as compared to the btree. Essentially, it's 1,000 times smaller in the example here. So the BRIN random size is 24 kilobytes, whereas the btree random size is 21 megabytes. So it's 1,000 times smaller, which is phenomenal. But let's look at some of the performance. So I think this was a 1,000,000 row table, and he's pulling back different numbers of rows from that table. So 100 rows, 1,000, 10,000, 100,000 rows. So how many rows you're pulling back from the table. Now the btree, whether it's random or sequential, the timings are pretty much similar, but the sequential is more performant by maybe a 2-fold difference in some of the cases. But it's pretty similar, but no more of a difference than that. So btree, whether random or sequential, the sequential is a little bit faster, but that's pretty much the result. Now the random BRIN index is just terrible. Its performance is worse than any of the btree, and it's consistently worse because it's essentially just like doing a sequential scan. It doesn't help at all. Now the BRIN sequential scan, as noted before, because it's indexing ranges, it can't pull out distinct values as fast. So actually the btree is about 20 times faster when pulling back 100 rows versus the BRIN index. At 1,000 rows, the btree is only about twice to 4 times as fast. And it's at the 10,000 rows you're trying to return mark where the BRIN is pretty much in the pack and matching what the btree does. And then it starts performing better with row counts above 10,000. Like the 100,000, it beat both btree examples. And then keep in mind, this is with an index that's 1,000 times smaller than a btree. So given the size, these are great results. And you can tweak the number of pages in a given range in the BRIN index. By default, it's 128, but he did test down to 4 different performance levels. So maybe by tweaking it, you could get a doubling, at most maybe a tripling in some performance for low row count levels. But you can check out this table for yourself. So basically in the conclusion, BRIN indexes are great when you have an insert-only pattern and the data is being added to the heap in a sequential manner. So think of a timestamp. And they're great for very large tables where you're wanting to pull back large amounts of rows. If you're wanting to pull back a single row or 10 rows out of a billion rows, the btree is going to be much more efficient at doing that. But if you're pulling back like a year's worth of data or a month or a week out of a table with millions, billions of rows, then a BRIN could give a lot of advantages. But if you want to learn more, definitely check out this blog post. The next piece of content, Postgres 15 improves UNIQUE and NULL. This is from rustprooflabs.com. And normally when you create a unique index or a unique constraint across columns, you can insert multiple nulls. And in this example that he created, he has a unique constraint on val2, and as you can see, you can insert as many null values as you want to into val2, and it's fine, because a null by definition means an unknown value, so you don't know if it's unique or not. So that's acceptable. But what's coming in Postgres 15 is that you can now use this additional clause called nulls not distinct. So what that means is consider null to be the same value, which of course means you can only insert it once. So in this example here, using that nulls not distinct, you can insert one null value, of course, but when you try to insert a second one, it's going to result in a duplicate key violation. So now, depending upon your use case, you can choose to consider nulls to be the same or to be different. If you want to learn more, check out this blog post. Next piece of content, introducing PostgreSQL 15, working with distinct. This is from Procona.com. And coming in the next version of Postgres is the ability for distinct to operate in parallel. So in this example here, they created 3 different types of tables, a 1-column table, a 5-column table, and a 10-column table, inserted a fair number of rows into each one, and then did a distinct from all the rows in each of these tables. And they actually tested in every version since Postgres 9.6. And as you can see, Postgres 15's performance is better than any prior version. And at the 10-column level, it's more than double the performance of even Postgres 14. And when you actually look at the explain plan, you can see that it's actually doing the distinct in parallel. Further, you can also adjust the max parallel workers per gather to get even greater performance. So if you want to learn more about this feature, definitely check out this blog post. The The next piece of content, 5 Minutes of Postgres, episode 26, new in Postgres 15, null handling in unique constraints and parallel distinct. And this is from pganalyze.com. And Lucas covers the previous two blog posts that I covered here, Scaling Postgres. So if you want his perspective on it, you can definitely check out this piece of content. The next piece of content, PostgreSQL 14 internals. This is from postgrespro.com. And this is an announcement of a book called PostgreSQL 14 internals that's been written. However, it's in Russian, but it is being translated into English, and part 1 of the book is complete already, and it's freely available here as a PDF. So if you're interested in learning more about specifically the internals of Postgres, definitely encourage you to go ahead and check out this PDF. The next piece of content, pgAgent, a Postgres exporter for Prometheus focusing on query performance statistics. This is from coroot.com, and they're talking about a Prometheus which does metric exporters to monitor different metrics of your system. Now, there exists a well-known open source one called the Postgres exporter that collects all sorts of statistics about Postgres to be able to query or to present to users, maybe using Grafana. But they had some issues with it because they wanted to ask specific performance questions, such as a CPU-intensive query is affecting other queries, or a server has reached max connections because most of the connections are stuck in idle and transaction, or an IO-intensive query is affecting other queries, or a query is blocking other queries by holding an exclusive lock. Now, they assessed that the number of changes required to get all of this information from the Postgres exporter would be, as they say, quote, too massive. So what they did is they decided to build their own exporter called pgAgent. So this blog post talks about that and also goes into some of the queries that they developed to be able to focus in on these performance pain points. And in the example here, they're showing top query time per second for different queries, query IO time per second, a report of client connections and some of their state, and also looking at different locks. And they give you a quick start on how you can get started using this new Prometheus exporter. So if you want to learn more about this new open source tool, definitely check out this blog post. The next piece of content, State of PostgreSQL, how to contribute to PostgreSQL and the community. This is from timescale.com. They're going back to the State of Postgres survey, and they're revealing questions with regard to contributing to Postgres, and looking at the number of people that have contributed to Postgres and in what way, along with some particular quotes with regard to it. And then it goes into how you could potentially get started contributing to Postgres. So if you're interested in that, you can check out this blog post. The next piece of content, Patroni and pgBackRest combined. And this is from pgstuff.github.io. And this post talks about if you're using Patroni to create a cluster of Postgres machines, how you can use pgBackRest to essentially back up that cluster. So if you want to learn more about how to do that, definitely check out this blog post. The next piece of content, the PostgreSQL Person of the Week is Charly Batista. If you're interested in learning more about Charly and his contributions to Postgres, definitely check out this blog post. And the last piece of content, we did have another episode of the Rubber Duck Dev Show this past Wednesday evening. This one was actually an interview with Brittany Martin, who is the host of the Ruby on Rails podcast. So we talked a little bit about podcasting, a little bit about project management, and some other topics. So if you're interested in a developer interview format, we welcome you to check out our show. That does it for this episode of Scaling Postgres. You can get links to all the content mentioned in the show notes. Be sure to head over to scalingpostgres.com where you can sign up to receive weekly notifications of each episode, or you can subscribe via YouTube or iTunes. Thanks.